Hello, welcome to WeatherWise. Once again, I am your host, meteorologist Nathan Scott. Today, we're going to talk about a term that you always hear with severe weather coverage. It's known as a TDS, or a tornado debris signature. We'll talk about how that all comes together in the first place, and when you hear that term, what you need to know exactly on how to respond when we say a TDS has been spotted. We'll talk about tornado warnings because not all tornado warnings are created equal. There are certain things that you should know as a viewer. And finally, we'll wrap things up talking about the difference, because a lot of people get these confused between a watch and a warning. And just because you're not under a watch does not mean you will escape severe weather all the time. So lots to talk about. We'll jump right in. A refresher of Doppler radar, because we have to talk about Doppler radar. I have an in-depth episode all about Doppler radar if you look back with earlier episodes, but let's take a look at what Doppler radar is. It is a tool that meteorologists use. It sends out a beam of energy, electromagnetic energy, and this sends a beam in two pulses. One is a horizontal pulse and one is a vertical pulse. And before, it was just one horizontal pulse until we got to about 2011 and 2012. Since then, with that horizontal and vertical pulse, it is now known as dual pole Doppler radar. And this tells us key factors on what's happening in the cloud. What I mean by that is the shapes. What kind of shapes do we see in the cloud? That's very important when it comes to tornado detection. Also, this beam, as it makes its way from the radar dome towards the cloud, it gets higher and higher above the horizon, above the surface, and we can actually change the angle of how that beam hits the cloud. And those are all important factors to keep in mind as we talk about tornado debris signature. So, when we talk about radar and tornado detection, the beam goes out. It's trying to figure out what kind of shapes we're dealing with. So this is an example of a sample of what the radar could see. We're going to use marbles. All the marbles are spheres. So pretty much all the shapes are similar. The precipitation is all the same in this example if we were talking about weather. So with this, it would be all raindrops or all snowflakes being detected by radar. When we talk about the shapes that the radar is seeing, this is known as the correlation coefficient. And when we talk about correlation coefficient, that is the relationship of what shapes are within the sample. If the shapes are all similar, we have what's known as a high CC, or a high correlation coefficient. Therefore, with this scan, if we were looking at weather, no tornado would be found with this scan because all the shapes are the same. However, let's mix things up. Let's take not only marbles, but let's throw some dice in and some other pieces from a game board. All the shapes in this sample are different. And in the weather world, that means the precipitation is different. It could be a mixture of snowflakes, raindrops, sleet pellets, but for severe weather, this could be leaves, tree branches, pieces of paper, books, clothing, whatever the tornado is picking up would amount to a mixed mode of shapes. And with all these different shapes happening, the radar would see the CC, or correlation coefficient, as lower numbers. It would be known as a low CC. And a tornado would be possible with this type of scan, but not necessarily happening. So when we take a look at the weather parts of all shapes being similar, this is what it would look like on radar when we take a look at the CC. The color would be pink or red. All the shapes in that circle are pretty much all the same. However, when you have a tornado picking up debris, you see a dropout in the CC, or it goes from the red spectrum into more of the greens and blues. And that is a tornado debris signature that was just from the last severe weather event back on April 20th, 2025. So this is the reflectivity view or the rain view of the storm. It shows heavy rain. We're looking at the border of Faulkner County, getting into Lono County, Pulaski County, just down to the south. Highway 319, Highway 5 was impacted by an EF1 tornado. You'll look at the radar data of this, and it does have that classic supercell kind of look to it. We've got the heavy rain to the north. We've got that appendage down to the south. Not much lightning with this, though, and that's because this event was what's known as a low cape but high shear. Therefore, the storms did not go way up into the atmosphere. The cloud tops were 25, maybe 30,000 feet, but if this was a high cape event, then those cloud tops would be more like 40, 50,000 feet. You would see a lot more lightning because these storms would be producing a lot of hail, and when you have hail and rain and all that mixing together and running into one another, that produces a lot more electric charges in the storm itself, and that's why you'd see more lightning. However, this did not produce a lot of lightning, and when you look at the radar reflectivity or rain part of this radar, you really can't find exactly where the tornado is. You might think it's down in this location closer to the 5 icon, but when we take a look at the velocity of this, there it is, the tight couplet, easy to spot. So this is a rain-wrapped tornado. You couldn't see it without really being right up to it because it was hiding within the rain cloud or the rain shaft. So there is the uptick in velocity or the winds, 85 mile per hour winds going into the storm. That was the inflow because we were looking at the radar from the North Little Rock radar dome, which is down to the southwest. So you had that core of yellow going away from the radar, and then you had that little bit of blue going towards the radar. So that's the downdraft or the outflow of the storm. The mesocyclone right on the border of Faulkner County, Lono County, and that white squiggly line right there, that is White County and the border of Lono County as this storm continued to push its way off to the north and northeast. Just because we have a dropout in CC does not mean it is a tornado debris signature. There are caveats. Sometimes the radar will have what's known as non-uniform beam filling or side lobe contamination. And trained eyes can only be really able to detect where this tornado debris signature is located. So once again, we're looking at the same case, EF1 tornado, April 20th, 2025, 4 different panels that show 4 different bits of information with this one storm. We've got the correlation coefficient in the upper left-hand corner. We've got the velocity. The color scheme is a little bit different than what I showed you earlier. This is from Storm Track 11 that I went back and saved those images. The reflectivity, the rain data of the radar is in the lower left-hand corner. And then Storm Track 11, great when it points out the rotation of the system. And you see that little bullseye right there with the blue and then the green popping up. The polygons or the boxes, those are tornado warnings that have been issued, of course, within this storm. So this is just before we start to see the tornado debris signature, because you see a lot of blue there, you see a lot of pink. It's a lot of noise. It's hard to find unless you know where you have to look. So we're looking at that location of where we have that couplet. When you take a look at the velocity in the upper right-hand panel, you have that little bullseye of green. So that's where the couplet's located. And what you have to do is match where that couplet is, where the highest reflectivity is with the rain, where the rotation is located, and then we're looking for a dropout or a change in the color scheme with the correlation coefficient. So we don't really see it just yet. Here's the newest scan. The rotation has picked up just over a couple minutes, and we're now seeing yellow with the rotation in the lower right-hand panel. The velocity, it's still there. The couplet's still there. The reflectivity it doesn't look so much like a hook echo, but there's a tornado hiding within that scan. Now going into it a little bit more, we're starting to see the actual evidence of a tornado debris signature. We still can't exactly tell you it's happening at this moment, just looking at this radar view of all this different information. But spotters were relaying to the National Weather Service saying that there was a tornado on the ground at this time. So can you find where the TDS is if you were a meteorologist? Once again, there's the couplet right there. There's the highest bit of rotation from our rotation pinpoint tool. But there is the tornado debris signature. It's right there. And watch what happens as we continue to advance this in time. It really starts to show up. There's a report of the tornado as it made its way from Pulaski County getting into Lonoke County, or excuse me, from Faulkner County getting into Lonoke County. And this green triangle right there, that is what's known as a tornado vortex signature. So this tool, the Storm Track 11 tool, will have the ability to say, okay, the rotation's really picking up in this cell, that the algorithm within this software can depict a higher chance of where a tornado could be located. Look at the rotation. That has also ticked up. It's now yellow. And anytime you see yellow with a tight couplet like that, your chance of a tornado happening at any moment or a tornado on the ground at the time certainly is much more of a higher concern. But what we're watching is that lowering of CC. So now we've had 2 scans of this showing up, and our confidence that this tornado is picking up debris is certainly continuing to be elevated, and we're saying, hey, this is a tornado on the ground now. We are about 2,000 feet above the surface once we get into this part of Lonoke County and eventually into White County. But there's the next scan. Nothing changes. Still see that clear blue area. So that tells us the tornado is picking up debris. It's picking up tree branches, leaves, shingles, parts of homes, causing a lot of damage. And with the radar technology, there's a lot of different shapes happening in this part of the area. Now, this blue area, that's just bad information. So we don't want to recognize that. But you want to match up everything. So we have the TDS, that matches up with reflectivity, that matches up with the velocity, that matches up with the rotation. We have all 4 pieces that all say, yep, this is definitely a TDS, and we have a damaging tornado happening at the moment. It's still there, even after another scan or so, but it does start to disappear before it gets just to the southeast of El Paso. Of course, that's where the track did end into that part of White County. And you can see the blue starts to mix in a little bit more because that debris, as it goes up in the cloud, it gets spread out more and more. And if it's a really strong tornado, you'll see a fanning effect with this. And that did happen with a Mayfield, Kentucky tornado just a few years ago. So we have the TDS, but let's even break it down a little bit more, because radar, like I said, that beam goes up. You can continue to aim that angle a little bit greater dependent upon who's using the radar. So this is the same TDS that we looked at, but now we're going to take the sample size and go higher and higher and higher into the atmosphere. So right now, we're seeing debris about 1,000 feet above the surface. This next scan takes it up to about 2,200 feet above the surface. Still, that low CC, that blue, is right there. So that tells us the debris continues to move up into the cloud. Now we're seeing the debris. This is above 4,000 feet. So when we have debris above 4,000 feet, we can actually get a gauge on how strong this tornado is by how far the debris is being lofted into the atmosphere. And then this is the final scan before it disappears at about 4,200 feet, because after that, we don't have any more of the lowering CC within this storm. Here's another look at it with Storm Track 11. So we're going to take a cross-section of this storm with the archive data, and look what happens. You see the blue, that lowering of the CC. That tells us that the debris was launched about 5,000 to 6,000 feet above the surface. So the tornado was picking up, once again, it could be paper, it could be books, it could be very light debris, or it could be shingles and maybe even some branches going that far up into the sky. Why is that important? Because knowing the height of the tornado debris signature can give us a perspective on how strong the tornado is. This is research done from the National Weather Service out of Jackson, Mississippi, and they have broken it down into a box and whisker plot. So basically, when you look at a box and whisker plot, we're looking at percentages. The bottom line of this box is within 25%, and then the top line of this box is within 75%. You're up to 99% with the top part of this line, and the bottom line that's getting close to 1% or so. You see this here with the max TDS height, and we could take this full if you want, just to get a better look at what we're looking at information-wise. But on the left-hand side, there is the max tornado debris signature height, starting from 0 all the way up to 40,000 feet above the surface, and then the tornado strengths at the bottom. There is a clear relationship. When you have debris launched, say around 4,000 up to about 7,000 feet into the air, you're going to have the best chance that it's an EF0 tornado. If it's a little bit higher than that, maybe 9,000 feet above the surface, then it's leaning more towards an EF1. Once you get above 10,000 feet with that debris being located by radar, up to 15,000 feet, you've got a strong tornado. That's a EF2. And then you see the trend. It continues to go up. So when you have a tornado that's picking up debris 25, 30,000 feet above the surface, that's a violent tornado on the ground. That's an EF4 or EF5. And we saw debris from the Cave City tornado earlier back in March. The debris was being launched up easily 20,000 feet, 25,000 feet. And that told us that this was a real serious situation. So knowing not just it's a TDS, but also how far that debris goes up to the atmosphere allows meteorologists to figure out, is this a weak tornado or is this a strong, possibly violent tornado? Anytime you have a TDS, tells you you've got a tornado on the ground. So next time you hear a meteorologist say, we've got a TDS or we're detecting debris on radar, that's when you really want to take the situation much more seriously. Coming up next, we'll talk about the different types of tornado warnings that you should know. For this next part, we're talking about tornado warnings because there are different types of tornado warnings. You've got the regular tornado warning, a general tornado warning. That's when you have a red polygon. And the only time that we change the colors of the polygons is when we use what's known as just the warning part of our radar system. That just shows the boxes of warnings, and we'll talk about the different colors. One may be red, one may be a darker red, but when you see the colors change, especially to a purple and a black, that means the tornado warning is getting a much more significant, and you really need to take your tornado precautions, especially if we have a confirmed tornado. So let's break them down here. The first one is a general tornado warning or a base tornado warning. We say tornado warning is in effect. It is detected with rotation by radar, or rotation is detected by the radar. A tornado is possible at any time. It may or may not happen. It most likely is going to be a wall cloud that's rotating, and we're seeing rotation, but as long as that rotation stays above the surface, you won't see a tornado. However, also, we issue a tornado warning if there is one occurring that we're seeing from a spotter report. Once that spotter report is confirmed, or if we start to see a TDS show up on radar, then we go from a general tornado warning to a confirmed tornado warning or an observed tornado warning. And anytime you hear this, that means a tornado is happening, whether it's detected debris on radar or spotters have seen a tornado and relayed that information to the National Weather Service. Spotters can tell you also potential strength of a tornado. If they're seeing a tornado pick up a home or pick up some large trees. If the TDS signature is getting more than 10,000 feet above the surface being detected by radar, then they'll go with a considerable tornado warning. And that means a strong tornado has been spotted or detected by radar because of the debris being lofted into the air. That's an EF2 or an EF3 tornado. So if we say there's a considerable tornado warning or the tornado warning has been upgraded to considerable, you've got a strong tornado that is happening in your location. You really want to take your tornado precautions and don't mess around. Finally, you have the emergency tornado warning. And this is when we have a large, violent tornado that's expected to have devastating impacts. That did happen with March 31st, 2023. They did issue a tornado emergency. That was a large tornado. It was an EF3, pretty close to an EF4. But when you hear an emergency tornado warning, that is 100% life-threatening situation. All tornado warnings, though, you should obey. Anytime you have a tornado warning and you're in that tornado warning polygon or tornado warning box and we're calling out your street name or we're calling out your community or city, you want to take action and get to your safe place immediately. Don't waste any time. Don't go outside looking for the tornado because something may not be happening right at that moment, but things could change drastically within a few seconds. So anytime tornado warning is issued, make sure you get to your tornado warning safe place. We'll wrap things up here on WeatherWise talking about the difference between a warning and a watch because so many of us still have trouble figuring out which one is which. And we're going to settle that debate coming up. What is the difference between a tornado watch versus a tornado warning? We get this question all the time here at THV 11, and when severe weather is happening, that's not the time to ask the question. So let's break it down for you right now. A tornado watch means conditions are favorable for the potential you could see severe weather. And if it's a tornado watch, it may be a tornado or it could be a storm that produces large hail or damaging winds. A tornado watch is issued for several counties, and it could be issued for several states for a long period of time. When a tornado watch is in effect, that's when you want to stay weather aware. Expect the chance of weather conditions to change rapidly throughout the day. It may be sunny right now, but in a few hours, things could go downhill very quickly. So anyone within a tornado watch or on the outskirts of a tornado watch needs to be prepared to take action. However, there are some times you have a tornado watch and nothing may happen. If we have a cap on the atmosphere and that cap holds or that lid on the atmosphere holds, no storms may develop across the tornado watch area. That happens a lot in Texas and also Oklahoma. Don't cancel any plans, but just stay alert and be prepared. Now, there's two different types of tornado watches. You've got the general tornado watch, and then you have something known as a PDS, a particularly dangerous situation. And this is issued when you have a moderate to high risk of severe weather. Anytime you have a PDS watch issued, that means the confidence of not only storms producing tornadoes has increased, but also the chance that tornadoes could be strong or violent. A PDS watch is when you really want to go ahead and plan in advance. It may just be one storm that produces a long track tornado, or it could be several storms. And if you live in a mobile home with a PDS watch, I would try to find a storm shelter or a friend's house that has a better way of safety, because you do not want to be in a mobile home or a manufactured home in that type of event if a tornado does actually happen during those type of days, because that is a life-threatening event when you have a PDS watch. Of course, a warning, that's when a tornado is expected or is likely to happen. We already talked about the tornado warnings. A tornado warning could take up a few counties. It may be for a small part of the county, but as you know, a lot of counties, even if it's just a small sliver of the county, will sound tornado sirens for the entire county. So the best thing to know is where you're located within that tornado warning box or polygon. If you're not in that tornado warning polygon, then your chance of severe weather is fairly low. But you still want to stay aware, just because a storm can change direction. So don't write anything off until we give you the all clear. You're in that red polygon, you're in that red box, you want to go ahead and take your tornado precautions. Hopefully you've learned a lot of stuff today here on WeatherWise. Always appreciate your comments, emails, and any ideas that you may have for future WeatherWise episodes. I'd really appreciate it. You can always send that to me on my Facebook page, or you can email it to me at nscott@tegna.com. Or excuse me, nscott@thv11.com. Tegna also works, though, as well. Thanks once again for tuning into WeatherWise. We'll have more future episodes coming up over the next several weeks. Have a great day.